Okay, today we're going to take some notes on the early astronomers. So you'll need to get out your science binders and start a blank page, and you can label it early astronomers. Now, we talked about how the early astronomy originated with the Greeks. So let's go over and review what the ancient Greeks did for us. They started very innocently. They just were looking up at the sky and mapping out the patterns the stars made, and they recorded these observations. They also found that these 5 points of light appeared to be different than the stars around them. They labeled these 5 points of light as planet, which meant wandering star in Greek. Now, they did not actually name each planet. The ancient Romans were actually the ones responsible for naming each of the planets. They named Venus, Mars, Mercury, Jupiter, and Saturn. These were the only 5 planets they knew about at this time. That's why you're not seeing all 8 of the planets we know about today. Now, they actually named the planets after their gods and goddesses that were important to them, and you can research actually how they came up with each name if you're curious. We're also going to talk about the common misconceptions or errors that these early astronomers held. One of them was quite funny, actually. They believed that we lived in a dome, kind of like in the movie The Hunger Games, where Katniss is put into the dome. They believed that we were all trapped in a dome and that the stars were just simply pasted on the top of the dome. They called this theory of living in a dome a celestial sphere. Now, obviously, that's not true, and we know that today, but at the time, they had no idea, and that was just one theory they held. They also believed that our solar system was a geocentric system. Now, geocentric means that everything revolves around Earth because Earth is in the center. Now, the prefix geo means Earth in Greek, so that is why they termed it geocentric system. We now know that we're actually in a heliocentric system where the sun is at the center, so we know this was false. But at the time, they didn't know. It was just a theory they held. They also believe that our universe is perfect and unchangeable, which we also know is not true. Our universe is always changing, and we're learning more and more about it as our technology evolves over time. Now, the first astronomer we're going to hit on is Ptolemy. He was a Greek astronomer. Now, this guy was like one of the first ones we learn about. He believed that our solar system was geocentric, which meant that the Earth again is in the center of the system and that everything revolves around Earth. He designed a diagram that explained how the planets move on little circles and then those little circles move on bigger circles. He claimed that this diagram explained why the planets move at different speeds and why some of the planets appear to be backwards. Now I'm going to show you a picture of this diagram. It's right here. As you can see, Earth is in the middle, and that each other planet has a little circle it's on, and then on that little circle it's on a bigger circle. Now, as you'll notice here, the orbits they're making is in a circular shape. We now know that our planets actually make an ellipse shape when they in their orbit, and so we know that that's false now too. Then comes along Copernicus, and poor Copernicus. He was a Polish astronomer, and nobody believed him. He was the one that said, hey, I think we live in a heliocentric system, or a system where the sun is actually in the center, and everything else, including Earth, revolves around the sun. Now, helios means sun in Greek, and his theory was not accepted until about 100 years later when Galileo added support to his theory. He too came up with a diagram. His diagram looked like this. You see the sun in the middle and then all the other planets on a big circular orbit shape around it. Again, he had that circular shape. We did not yet know that they were on ellipse shapes. Then comes along Galileo, who proves poor Copernicus' theory. Galileo was an Italian astronomer, and he also believed in the heliocentric system. He found 2 big evidences to disprove the geocentric system. Now, Jupiter, he found that had 4 moons that revolved around Jupiter, not Earth. So he said it wouldn't make sense if Earth was in the center and everything revolved around Earth because Jupiter has 4 moons that revolve around Jupiter, not Earth. So that proved that the geocentric system was actually false. He also found that Venus went through phases similar to our moon, and that it wouldn't make sense if we lived in a geocentric system if Venus went through phases similar to our moon. After Galileo's support he found for the heliocentric system, we began calling it the solar system rather than the Earth system because we found out that we were actually all revolving around the sun rather than the Earth. Now, Galileo also was important because he was the first to use a telescope to look at the objects in the sky. We know that Galileo was not the first to make a telescope. We know that many scientists played the role in helping create the invention of the telescope, but he was certainly coined with the first to look at objects in the sky with a telescope. And he lived 100 years after Copernicus. Now, next we have Brahe, who's a Danish astronomer. He made much more accurate observations in the late 1500s. Those observations came in later when Kepler started to use those observations to find out what shape each planet's orbit made. He carefully observed the position of the planets for almost 20 years and just wrote down these observations. Observations are hugely important in science because they come back later as proof of theories, which you're going to find Kepler used to his advantage. Kepler, who was a German mathematician, in 1600 analyzed the data and observations that Brahe made. He wanted to figure out the shape of the planet's orbits. He was not convinced that they made a circular orbit shape. He discovered that the orbit of each planet is actually an ellipse, and an ellipse is just a fancy word for an elongated circle or oval shape. He studied Mars, and he found that his calculations fit Brahe's observations better when he used an ellipse shape rather than a circular shape, so he concluded that each planet actually follows an ellipse orbit rather than a circular orbit. So Kepler was huge in helping us identify the shape of the planet's orbits. Then comes along Sir Isaac Newton. Now, we know he's famous. He was an English scientist, and he said, okay, Kepler, I understand that each planet makes an oval or an ellipse shape orbit, but how do they stay in their orbit? And he concluded that two factors contributed to how these planets stay in their orbit: inertia and gravity. So let's talk about inertia first. Inertia is the tendency of a moving object to continue in a straight line or a stationary object to remain in place. So if I'm moving in a straight line, inertia is going to help me keep moving in that straight line. If I'm standing still, inertia is going to be what helps me to stand still. The more mass you have, the more inertia you have. The less mass you have, the less inertia you have. So I, who have a very large amount of mass, am going to have more inertia than you have because you're less mass or less weight. So you have less inertia. And inertia is what keeps the planets moving forward in their orbit. But what keeps them in their orbit? Well, that is contributed to gravity. Now, gravity is the attractive force between two objects. Its magnitude depends on their masses and the distance between them. So basically, the gravity between the planet and the sun is what holds it in its orbit. How much gravity we have depends on the mass of the planet and the distance between that planet and the sun. So the sun's gravity keeps that planet in its ellipse orbit, and inertia is what keeps that planet moving forward in its orbit. So both those play a vital role in keeping that planet in its orbit and moving. Now, this is what we have talked about all last week. Make sure you take thorough notes throughout the video. If you need to replay the video more than once, feel free to do so. And if you need to pause to write down a slide longer, feel free to do that as well. But make sure you take thorough notes because you'll need those for the test. All right, thanks for watching, guys.